In this video, we'll be looking at adding and subtracting fractions. We will be using the LCM, the least common multiple, as we do some of these examples. And when it comes time to finding the LCM, we will be using prime factors. The first and most important thing to know about adding and subtracting fractions is that you need a common denominator. Here's an example where we do have a common denominator. Our bottom number in both fractions is an 8. So we have same number, a common denominator. So we can proceed right to our answer. We should know that once we do have a common denominator, our answer also will have that exact same common denominator. The operation that we do is with our numerators. That 7 plus 5 equals 12 up in the numerator. And let's actually finish this problem up. We should simplify this. I'm going to choose to use some prime factors. 12, I found 2 times 2 times 3. 8, 2 times 2 times 2. And any factor that we see the same in numerator and denominator, we can cancel out. So I've canceled a set of 2's and another set of 2's. And no more factors can be canceled. So we're at our answer, 3 over 2. So just a quick example of how straightforward it is when we do arrive at a problem where the denominators are the same. And this works whether our common denominators are just numbers. It would work if we had some variable expressions in our denominator also. All we care about is that they are the same. So we know our answer will also have a denominator of 3x. And just look at our numerators. 11 minus 4, 7. And there's no canceling here. In fact, 7 is a prime, and 3 times x, those are each primes, so no factors can be canceled there. There's our simplified answer for that example. But let's move on to some examples of problems where we do not have a common denominator. Here's one, 5/3 plus 5/2. To find the common denominator is to find the LCM of these two denominators. And in fact, you maybe hear LCD, or least common denominator. Well, LCD and LCM are pretty much the same thing. LCM is more general. LCD means we're finding the LCM of some denominators. We're specifically going to use it for fractions. And LCM, it's definitely used a lot in fractions, and it's used a lot elsewhere also. So they're really the same thing. LCD is just being more specific that we're going to be using it as a denominator in some fractions. So our common denominator is going to be the LCM of our two denominators. So let's do some work. I like to go right here next to the problem to find my LCM. This one won't take too much of a breakdown in terms of our prime factors, just a smaller example to get us going. But I'm thinking about up here is where I'll do my factor trees and build the LCM. Now 3 is already prime number. Same thing with 2. So when I go to build the LCM, I need some 2's and 3's, but I need just 1 2 and 1 3, and our LCM is 6. Now, if you looked at these two denominators and said to yourself, I can see mentally that the LCM is 6, then I wouldn't go through all these steps. But we will face problems where the numbers are a little bit larger. In the future, you deal with more variables, and in that case, this sort of an approach is much more useful. So that's why I always emphasize it. The next part of this problem is how do we take these fractions and turn them into new fractions that will have a common denominator of 6. Well, I'm going to, down here, rewrite the 5 over 3 and the 5 over 2. And I'm also going to write that this fraction, I want to have it somehow equal a new fraction that has 6 in the denominator. I'll do the same thing with the 5 over 2. So I'm leading myself towards these new fractions where the LCM is down in the denominator. The way that we change fractions is almost always either we multiply the same thing to numerator and denominator, or we divide the same thing from numerator and denominator. But the theme is, in order for us to not change its actual quantity, to keep this number as what it is, 5/3, we have to do the same thing to top and bottom. So if I think about, I'm sitting here with a denominator of 3, and I want it to end up being a 6, I need to multiply something to 3 to get up to 6. I need to multiply by 2. And if I choose to do a times 2 to the denominator, we have to do a times 2 to the numerator. And 5 times 2 equals 10. So 5/3 and 10/6 are actually equivalent. They are the same value. They're using different numbers, but in terms of what value they are exactly the same. If we were to look at them on a graph, they would be the same thing, equivalent values. And that's because we multiplied the same number to top and bottom. So we have to do the same sort of approach with 5/2, but this time, what is it that we need to do times 2 to get up to 6? Well, we need to do times 3. And if we do it on the bottom, we must do it on the top. Now, let's knock out that 5 times 3, 15. I want to go back and talk about this part here where we said, well, what's missing? What do I need to multiply to 3 to get us up to 6? And here's one reason why I love using the prime factors, because we have 6 broken down as 2 times 3. So if I see a 3 here, I'm thinking, oh, I've got the 3 covered, but what's missing? The 2. And that's what we needed to do to top and bottom. And over here, we had the 2, but what was missing? The 3. And that's what we did to top and bottom down here. And we'll emphasize this idea with the next few examples, but we're pretty close to the ending here, so let's knock it out. We just did a lot of work to find some common denominators, but the hard work is done because now we know our answer also will have that same common denominator 6. And the operation, the math that we need to do, is with our top numbers, the numerators. So it's 10, check back here, that's a plus, 10 plus 15. So we have 25 in the numerator, and 25/6 for our sum of adding these two fractions together. Let's do a quick check to see, can we simplify this fraction? If I go to prime factors, I see 25 is 5 times 5, and 6 is 2 times 3. I don't see any factors that are the same in numerator and denominator, so nothing can be canceled here. So it turns out that 25/6 was already in lowest terms, and that's our answer. So think about these problems in our big chunks here. The first thing we had to do was find the LCM. The next thing we had to do was get equivalent fractions, change our old fractions into new fractions that have that LCM, and then do the math and finish. I want you to try this example. So pause the video, or perhaps even jot this problem down and rewind to the previous example to see our steps through these problems. Remember, we're going to need to find the LCM and then get equivalent fractions and then do the math and finish it up. So go ahead, pause the video, and when you've worked through it, restart, and we'll look through this answer together. So here's my approach for this problem. First, I needed to find LCM, and it wasn't as easy as that last example was, but I start with the 12 and prime factors of 12. So first I went for 2 and 6. The 2 is prime. The 6 we can break down further into 2 and 3. Next, the 10, we can break this down into 2 and 5. And finally, build the LCM. So we'll have to use them all. Where do we see the most 2's? Right here, we've got 2 of them. Where do we see the most 3's? There's 1. And here's where we see the most 5's. We see 1. And those all multiplied together give us our LCM, 60. Okay, part 1 is done. Part 2, we take our 11/12 and our 1/10 and figure out what do we do to get these up to new fractions with denominator of 60. And maybe some of these, what number do we need to multiply? That might jump out at you, but I'm going to have you focus over here on the lists instead and think about what's missing if we compare 12 to 60. Okay, look at 12. It has 2, 2, 3, and 60 has 2, 2, 3, and 5. So if I compare my lists, 12 currently has both 2's and the 3, but it does not have the 5. And that's exactly what we need. 12 times 5 is 60. So maybe we know 12 times 5 is 60. Maybe we do the inverse operation. We do 60 divided by 12. We can get 5 that way. Or if we're nice with our lists, we can just consult up here and look for what's missing. What is the missing factor? Okay, let's finish this equivalent fraction. 11 times 5, 55. Down here, what times 10 to get us to 60? Well, hopefully that 6 is jumping out at us. But if not, let's go back to the lists. 10 has 1, 2, and 1, 5. So we've got 1, 2 covered. We have the 5 covered. What are we missing? We're missing these two guys, the 2 and the 3. And what's 2 times 3? 6. 10 times 6, 60. 1 times 6, 6. Now let's finish this one up. With the way I do these problems, it is important right here after we get our equivalent fractions, make sure we take a quick check up here and see that this was a subtract. So we definitely have an answer that is over 60. That LCM always will show up in our answer. And 55 minus 6 for the numerator, 49. If I think about, can I simplify? Well, factors of 49, the prime factors are 7 times 7. And I already know about prime factors of 60. I have them listed right up there, 2, 2, 3, 5. And I won't see anything to cancel. So this was one already in lowest terms, 49 over 60. Here's another example for you to try. So pause this video, work through this problem, and once you have an answer, restart and we'll look through this answer together. So hopefully you started with finding the LCM and the LCM of our two denominators. First, prime factors of 15, 5 times 3. Prime factors of 6, 2 times 3. Our LCM, I've got 1, 2. When it came to 3's, 1 was sufficient. Here's 1, 3. There's 1, 3, so 1's enough. And 1, 5. And 2 times 3 times 5 equals 30. Next, the equivalent fractions. I have rewritten 14 fifteenths and 5 sixths. And here's our ending point. I want fractions with our LCM, 30, down there in the denominator. 15 times what equals 30? Either we're seeing 2, or you're looking at the list and seeing that 2 is missing. We have the 3 and the 5. We don't have the 2. Top and bottom gets times 2. And our 14 times 2 gives us the 28. With 5 sixths, we needed top and bottom times 5. 5 times 5, 25. All right, we know about our answer. It has denominator of 30, and its addition, the 28 plus 25, gives us 53. And as it turns out, 53 is a prime number. There's no simplifying we can do. It's our final answer in lowest terms, 53 thirtieths.